I'll be taking short pieces of discussion. Okay, we have been discussing 5G, and just a quick reminder that there are three basic classes of requirements for 5G. Uh, and these three motivations or different to address the diverse use cases is well demonstrated in this figure. Yeah, here you see there are so many applications. Okay, you uh, you can actually understand any of these uses, what they are: wearable or gaming, virtual reality. You're familiar with all of them. But the point is, in some cases, you need high data rate. Okay? I mean, uh, the three different classes of the three different motivations. Okay? Uh, bring the different use cases towards uh, any of them. Okay? And so the position of the use cases show how close to the extreme uh, extreme state of the motivation. Okay? For example, for video, okay, for live streaming video, the high data rate is the only concern. So reliability, you don't care. Okay. Also, the number of applications as such will be very small. So you are farthest from these two extreme states, okay, of these two motivations. So anyway, the point is there is to address so many different types of use cases. Uh, there are many different ways the specifications have been facilitated, and also different flexibility has been incorporated or deployment. The different operators vary in their choices. Uh, and we have been discussing actually how these things have been incorporated in 5G. Okay. In our last class, we were discussing uh, the common resource block. We'll go back to that page. Okay, we are showing here, we have come to the different duplex modes. We have discussed them. Uh, but let me tell you that this supplemental downlink, okay, finds its major application. I mean, in this case, we showed uh, in the operating bands, local operating bands, that we have separate bands for SDL uh, or SQL operations. So we allocate some bandwidth from there. But this SDL can find different use cases, but one of them can be TV, where you have only broadcast or only data flow in downlink. There is nothing for the user to send. Okay. However, in the case of SUL, supplemental uplink, it is almost always linked with a pair uh, of I mean, it's linked with a bidirectional data flow. Okay. So you have, say, for example, in your ordinary FTD band, you have SDL. These things actually were incorporated in 4.5G. Okay, in this additional bands. Um, anyway, so in the FTD band, you already have a bidirectional data flow allocation. You have allocation in the uplink, you have allocation in the downlink. But in the uplink, you may need high data rate. So you may have another allocation in SQL. However, at a time, you are not. So if in the same slot, you're not allocated uh, resources from both uplink parts. I mean, you have a part of bandwidth. You have some bandwidth in the FDD region. And for SQL, the operating bands are uh, away, away from FDD bands. So there'll be good separation. So the EV is never allocated resources from both uplink bands. I mean, it is allowed to use them, but not concurrently. Okay. On some slots, you may use from here, from other slots. So the network may uh, make use of some efficient uses of whatever resources it has. So for high data rate, is even that part may be useful. Okay, then we were discussing. Okay, this page lists the major specification numbers for 5G CGPP specifications. I mean, numbers along with their titles, titles of the specification book. And you see for Mac, uh, I mean, if you look at say 25.321 is the Mac protocol, Mac specification book for 3G. If you look at 36.321 is the Mac specification book for LTE. And 38 series for 5G. Okay. Similarly, the same applies to RLC, PDCP, 323. Okay. And I told you before that RC is most important for us. 331. I have already shared this 38 the 331 the specification book in the Google Drive in the folder book. Okay. And convert it into PDF, then upload it because it's easier to handle. It's a large file, so easier to handle when you use PDF. Okay, and these are the physical layer procedures. There are many other specification books which define different things for 5G. Okay. It's not that I mean 38 is dedicated for 5G, but a lot of things are correlated. You will find them in other specification books. I've uploaded release 16 version. Uh, I mean around the middle of this year of 2020. Okay. Release 16 started to release. Okay, find out where we were last time. I think it was, yeah, the frames and slots. Yeah, here we are. The common resource blocks. Okay. There's actually a particular point defined, point A. You may have different subquery spacing. You may want to use different subquery spacing in your system. We previously explained why you may use uh, different subquery spacing. If you want to use uh, I mean, multiple subquery spacings together, you can also do that. Now, they will be, they will have the position of frequencies, okay? Sort of look, I mean, located this way, the way shown. Now you see that there are resource blocks. The resource blocks are, will be just wider, um, uh, depending on the sector spacing. If it is double, the resource block is also twice as much as what you had for 50 kilohertz. So linearly, you have a wider. This is this way, horizontally you have frequency. So it shows the different resource blocks, the resource block 0, 1, 2, 3, this way. For 30 kilohertz, it's longer. So if you have multiple uh, factor spacings, then the resource blocks will be aligned this way. Uh, their relative position will be like what is shown here. And the frequency, okay, which is at the center of the first, uh, in the research blocks, you have 12 subcarriers. So the first subcarrier position is called point A. And that's the point, just for all of them, okay, to see how they're located. So it's just a reference with which the research blocks are have positions shown as shown here. Okay. Now the UE determines. We know that now we know how the UE captures the network after you power up. Okay. So remember, you have the basically the same steps here. Okay. Just to help you remember, I'll tell you the steps again. So what you had in LT, you had, you first perform synchronization. Okay. There is a synchronization signal with that you perform synchronization, so you can find out where the frequencies of the operating bandwidth located. Okay. So here, when you do that synchronization with this, similarly you have synchronous signal, and when you perform synchronization, you can find out point A. So you know the related positions, and also you can find out PBCH. PBCH is the broadcast channel that sends me master information block. That's a uh, system information, but it is shorter and is the one that you captures first after it is powered up. So it is called master information block. All others are called SIP, but this one is called. Now that is mapped on a different logical channel, PBCH. Other channels are mapped on PDSCH. Okay, in this true for both LTE and 5G. So when you capture, after you capture synchronization signal, you can find out the location of PBCH. This is true for both LTE and 5G. When you have synchronous signal, you know where the center frequency is. You know where the slot boundaries, already different boundaries are. And I did not exactly showed you the position of need messages, but it is my book explains you have a position for me, certain position for me in the time frequency grid. So once in LT, now I'm talking about LT. In LT, when you capture sequence signal, you find out the location of MIB. Then you can read MIB. Okay. And MIB helps you to read CTEC1. Actually, meet tells you in the case of LTE, meet gives you the bandwidth. So once you know bandwidth, the slot boundaries, you can read PCFICH. From there, you can read PDCCH. From there, you can read SIP type 1, PDSCH. And from there, actually, you find out the parameters to capture the cell selection parameters, the cell selection parameters you need to camp on the cell. So uh, you get them on SIP type 1. Okay. Similarly, you have here, you capture the signal, and then I'll shortly show you that you also can capture PBCH, or actually the mid message, and mid message lets you decode SIP 1. Okay, so you can then camp on the particular cell. So these procedures are very similar. Now the bandwidth parts are required. Okay, give me a second. Let me terminate for now. I'll create a new session.